All right, hello again, everyone. Today we're going to be reviewing some more properties of exponents. Yesterday we dealt with a lot of rules that allowed us to add or subtract exponents together, and today we're going to be looking at some that allow us to multiply exponents together. So this first one we have is called the product of powers, and so if we have an expression x to the a being raised to a different exponent b, we can take the two exponents a and b and multiply them together. So if we look at this first example over here, we're given 2 to the third, all raised to the second power. So we could solve this without our product of powers rules by simplifying inside of the parentheses first. So 2 to the third is the same as 2 times 2 times 2. And 2 times 2 times 2 is 8. And then 8 squared is 64. But by using the product of powers, we can avoid needing to simplify the inside of the parentheses first. So if we look at the problem again, 2 to the third squared, since we have this exponent on the inside as a, this 3 is a, and this 2 is b, there we go, b, we'll just multiply those two together. So we'll have 2 to the 3 times 2, as per our rule up there. And so we know 3 times 2 is 6, so that gives us 2 to the 6th. And when we simplify that with the calculator, that's 64. So we still get the same answer, but we didn't have to simplify inside of the parentheses first. We're just able to find an exponent that gave us our answer. So if we look at this next example over here, we're given 3x to the fifth, y to the negative 2, all to the third. So this 3 right here has its own exponent. It's 1. There we go. It's 1. So we'll still need to multiply this 3 over here by that 1 when we're simplifying this. So we'll go ahead and distribute the 3 throughout to each term. And so we're given 3 to the 1 times 3 times x to the x's exponent is 5 times 3. And we're given the y's exponent is negative 2 times y to the negative 2 times 3. So now we can just go through and simplify each of these. So we're given 3 to the 1 times 3 is 3 cubed times x to the 5 times 3 is x to the 15, and y to the negative 2 times 3 is y to the negative 6. So we know that 3 cubed is 3 times 3 times 3 is 27. We have x to the 15, y to the negative 6, but we can't have a negative exponent in our answer. But if you recall from yesterday, we had the negative exponent rule. And so when we have a negative exponent, we can take that whole term and flip it into the denominator. And so that gives us a new answer of 27x to the 15 over y to the 6th. So that is the product of powers rule. So now let's look at the power of a product rules. So this is saying if we have two different terms, x and y, being raised to a an exponent a, we can take that exponent and distribute it to each term individually. So if we look at this example here, this first one, 2x cubed, y to the 4th to the 3rd, we'll just go ahead and put that 3 on each exponent. So this 2 has its own exponent of 1 again. So we'll take the 3 and have it multiplied by that 1 using our product of powers rules from last time. So we have 2 to the 1 times 3 times, now we'll distribute the 3 onto the x term, x to the 3 times 3 lastly, we'll put it onto our y term times y to the 4 times 3. And we'll simplify from here. So 2 to the 1 times 3 is 2 to the third. So 2 to the third. And we know 2 to the third is 2 times 2 times 2, which is 8, times x to the 3 times 3 is going to be x to the 9th. And y to the 4 times 3 is going to be y to the 12th. So our answer is 8x to the 9, y to the 12, because we don't have any negative exponents in there that we have to worry about. So if we look at this next example, we're given x to the 4th, y to the negative 2, raised to the 3rd power, times x to the negative 4th, y to the 5th. So let's look at this term first, this x to the 4th, y to the negative 2 to the 3rd. We'll go ahead and distribute the exponent of 3 to both of these terms. So when we do that, we have x to the 4 times 3 times y to the negative 2 times 3. And that is the same as x to the 4 times 3 is x to the 12th. Y to the negative 2 times 3 is y to the negative 6. And now we'll bring the second term back in, because this was still multiplied by x to the negative 4th, y to the 5th. And now, if you remember our rule from yesterday, since we're multiplying our multiplying these two different variables together, we're going to add the exponents. So we'll take the x's, so x to the 12th times x to the negative 4th is the same thing as saying x to the 12 plus negative 4. And 12 plus negative 4 is 12 minus 4, which is x to the 8th. And then our y's is y to the negative 6 times y to the 5th, which is y to the negative 6 plus 5. And negative 6 plus 5 is the same thing as y to the negative 1st. So that makes the simplification now x to the 8th, y to the negative 1st. And so now we have this negative exponent in. So we'll have to flip it to the denominator to make it positive. And so that will make our final answer x to the 8th over y. The last rule we're going to cover today is called the quotient of a power. So this is if you have a term, an expression, x over y. So you've got the quotient there, and you're raising that whole thing to an exponent a. You can distribute that exponent both on top and on bottom. And something that I find important to note is that when you distribute it to the bottom, it does not become negative. It's still positive. So an example of that would be this first one over here. We have x to the 4th over y to the 7th. Since they're different variables, x and y, we can't just combine them, so we'll use the quotient of a power rule to simplify this. So this is the same as saying, so we've got, once we distribute this through, we'll distribute the 5 on top, and we'll distribute it on bottom. We have x to the, if you remember back to the first rule, it becomes x to the 4 times 5 over y to the 7 times 5. And we can just simplify this from here. So x to the 4 times 5 is the same as x to the 20 over y to the 7 times 5 is y to the 35. And we can't simplify this anymore, so that's our answer. Now, this last example that we have, we've got the expression 2x cubed y to the 6th over 4x to the 4th y cubed, and we're raising the whole thing to the second power. So I'm going to rewrite this, make it a little bit larger, because we can simplify inside of this expression first and then take it to the second power. So let's look at our numbers first. So 2 over 4, we know, reduces to, if we divide both of them by 2, we're just left with the 2. So we've got 1 over 2. Let's look at our x's now, since that's the next term, times. Now we have 3 x's on top, so we have x times x times x. And we have 4 x's on bottom, so x times x times x times x. So if we were to flip this x to the 3 on top, then we'd just have that, if we were to flip it to the bottom, then it'd be a negative 3. And we'd have x to the 4 minus 3. So we can cancel out 3, and we're left with 1x on bottom. So we're left with times 1 over x over here. And then lastly, our y's, we can do the same thing. So this is the same as y times y times y times y times y times y. And this is the same as y times y times y. So we're able to cancel out 3 of the y's on top and all of them on bottom. So we're just left with a y to the 3rd on top. So if I rewrite this down here, we're left with 1/2 times 1 over x times y to the 3rd. And this whole thing, now that we've simplified the inside, is raised to the second power. So we can go ahead and distribute that throughout. So we've got 1 squared, which is 1, because it's 1 times 1, over 2 squared times, we've got 1 squared, again, which is 1 times 1, so still 1 over here, over, we've got x to the 1st here, so 1 times 2 is x squared, and then the last we have y to the 3 times 2, so y to the 6th over, we've got 1 squared again, so 1. And now when we simplify this, 2 squared we know is 4. So we're left with, if we look at the top, we've got 1 times y to the 6th, so y to the 6th over 2 squared is 4, and then x squared times 1. So that's our final answer. And we were able to do that by simplifying first before we distributed that exponent throughout. So look for that in some problems because it can save you a lot of time and effort when solving these sorts of